Hello, greeting students, and welcome to a new video. In this lesson, we will continue with lesson 5.3 Forces in Two Dimensions Part 2. We will explain the concepts and solve related questions and applications. So let's start. Adding forces in two dimensions, the magnitude of the net force or the two forces at right angle can be found using the Pythagorean sum. The relationship that we should use in order to find the magnitude of the F net is given by F net is equal square root F1 squared plus F2 squared, where F1 is the horizontal force, F2 is the vertical force. Now, as a result, we were able to obtain the net force, and in order to draw the net force, we should complete the figure into rectangular shape, like this. The diagonal of this rectangular shape will represent the direction of the net force. Now, this direction can be found graphically. We'll see later how we can find or determine the direction analytically. Now, remarks, the Pythagorean sum can be applied to the perpendicular forces or vectors to find the net force or net vector. The net force is represented by a diagonal of rectangle formed by the two forces. Now, in order to clarify the idea and the usage of the FNet, we need to show that using some examples. Now we can solve application 1. Determine the magnitude of the net force in each of the following cases, then draw it. So let's start. Now for the first figure, in part A, we have two forces, F1 and F2, where F1 is given by 30 degree and F2 is given by 40 Newton. So F1 is at 30 Newton and F2 in 40 Newton. To find the F net, since the two forces are at 90 degree, then in order to find the net force, we need to apply the Pythagorean sum, F1 squared plus F2 squared. So let's substitute the values for F1 30 squared plus for F2 is equal 40 squared. F net is equal, plug everything in the calculator, and we will get the value of the F net, and the F net in this case is 50 Newton. Now in part B, we need to find the magnitude again, but this now, or in this time, F1 and F2 are not given. However, by using the grids and the scale provided on the grids, we can find the magnitude of F1, the magnitude of F2. So let me write here that the magnitude of F1 is, we have two squares vertically. The scale is 50, so 2 times 50 is 100 Newton. As well as for F2, we have two squares times 50, another 100 Newton. Now, since F1 and F2 are at 90 degree or right triangle, then the only way to combine them together in order to produce the F-net is by applying the Pythagorean sum, and it's written as F1 squared, F2 squared, plus and the square root, which is equal 100 squared plus 100 squared, and the answer is 100 radical 2 Newton. For sure, we can express the same result in decimal form. Now, what about part C? In part C, again, we need to find the magnitude of F1, F2, F3 in order to complete the solution. For F1, the F1, we have three squares, and vertically, each square is equal to 0.75. So 3 times 0.75 is equal to 2.25 Newton. For F2 is 1.5 Newton because we have only two squares times 0.75 is 1.5. And finally, for F3, we have three squares, 3 times 0.75 horizontally then the answer is equal to 2.25 Newton. Now, in case we have more than one force along specific axis, such as like this case, we have F2 and F3 pointed along the same axis, then first it's better to find the vertical component or resultant of the vertical forces. So let's call it Fv, and Fv is given by the two forces minus 1.5, and the minus here stands for what the direction? The direction here is downward. Now, again, 2.25 is also downward, so we should use the minus sign. And the answer of Fv is 3 minus 3.75 Newton. Now, let me redraw the sketch to include the Fv. And what about the Fh? Fh is the horizontal force, which represent all the forces or the net forces acting along the horizontal direction. However, here along the horizontal direction, we have only and only one force, which is 2.25 and is directed or pointed to the right. This is why Fh is represent F3. So we can write that Fh is the same over 3, and in this case, F3 is equal to 2.25 plus 2.25 Newton. Now, since we have two forces at right angle, then in order to combine them together, we should use the Pythagorean sum. So F net is equal Fv squared plus Fh squared. So Fv is minus 3.75, and I want to grab your attention that whenever we want to square the force or the vector in the Pythagorean sum, we should always use a bracket to include minus. Whenever we have minus, we should put the minus between the bracket to apply the square for the number, the magnitude, and the direction. However, in the previous cases, we didn't do that because the components or the forces of 1 and of 2 were positive. So the bracket won't affect the process or the final answer. Only for the minus, to ensure that the minus included with the square should add the bracket. So plus, now Fh is positive, so no need to include the brackets. If you would like to add brackets, it's fine with the square. Now let me use the calculator to show you how we can calculate the magnitude of F net. So we use the square root with the bracket minus 3.75 square plus 2.25 squared. And the answer is, in decimal form, 4.37 Newton. This is the magnitude of the F net. So let's go to the next section now. Let me make some space here. Now again, here we need to find the magnitude of the net force in each case, then draw it. So let me show you how we can find the F net. So first we need to determine the magnitude of each force. Let's start with F2. The magnitude of F2, the number of squares from the scale, 1, 2, 3, 4. 4 times 2 is 80 Newton. For F3, there is 3 squares. 3 times 2 is 60 Newton. 1, 2, 3, 4 squares for F1. 4 times 2 is 80 Newton. And finally for F4 and F5. For F4, we have 2 squares times 2 is 40 Newton. And here we have 3 squares times 2, 60 Newton. Now let's determine the net forces along the horizontal together, and then we're going to determine the net forces along the vertical to obtain the VF and VH. So let me start with VFV, the vertical forces. We have 6 up, so plus 6, 8 down, so minus 8, and the answer is minus 2 Newton. This is the FV. Now let me make a small sketch for the FV, which represent all the forces or the net forces acting along the vertical. Now what about the FH? The forces acting along the horizontal. Now we have plus 8 to the right, so it must be plus. To the left, it's minus, so minus 4, minus 6. And the answer is minus 2 Newton. So F minus 2 Newton. Minus means the direction is in the opposite, to the positive sense. The positive sense is to the right, so the opposite will be to the left. Finally, we need to find the F net. Remember that whenever we have perpendicular forces at 90 degrees, we always add them or obtain the resultant of these two forces using the Pythagorean sum. So VH squared plus FV squared. Now FH is given by minus 2, so minus 2 squared plus minus 2 squared, and the answer is 2 radical 2 Newton. This is the F net. How we can draw it? Remember that to draw the F net, we always use, we complete the shape to the rectangular shape with this one. This is the rectangular shape, and then we connect the corner to the corner, or we construct the diagonal. This diagonal will indicate for me the direction of F net. So this is the direction of F net. Now in application 2, given the magnitude of the net force is F net is equal to 15 Newton. So here, as you can see from the question, they provide me with the F net. They won't ask me about finding the F net, they already give it to me. Now we need to calculate the magnitude of F1. So according to the sketch here, or the diagram provided here on the left-hand side, we will notice that F1 is known. It's equal to x in Newton. We don't know what is the numerical value here, and they asked me to find this numerical value. It's obvious that the direction of F1 is to the right. However, usually when we want to analyze the forces, they will ask me always to find the F net, but here in this time they asked me to find the to find one of the forces, and they provide me with the F net. However, in this type of questions, we will follow the same procedure that we used to do to solve and find the F net. Even if they provide me with the F net, I will assume that the F net is not given, and I will start solving the question to determine it. And in order to determine the F net, we usually combine the vertical forces together, the horizontal forces together, and then we apply the Pythagorean sum to find the resultant, because we will end up with two perpendicular forces. Now let's try to do that again in this question. So I will combine this force to that force vertically, and these two forces together horizontally to obtain FH and FV. So let me write here. So FH is equal, horizontally we have only two forces, X and 8. Both of them are pointed to the right, so X plus 8. Newton, this is the horizontal forces. Although the X is not given here, the value or the magnitude of F1, I will keep it the same without any changes, and I complete the question or the solution to find the F net. So FV is equal, now vertically we have two forces here. The 3 and the 12. The 12. 3 is up plus 3, and 12 is downward, so it's minus 12. Now, after we do the calculation, we'll get it with minus 9 Newton. Now, let me construct the Fnet. The Fnet is equal square root of FV squared plus FH squared. Let me substitute everything in this formula. But this time we're gonna use the 15 because it's already given. So the 15 is equal, the net force is equal square root of the F vertical, which is in this case minus 9. So minus 9 between a bracket plus, and the x plus 8 is the horizontal, again between a bracket, squared. Now this equation is the equation we're done on that. We have multiple ways to solve this line. However, it's easier if we remove the square root from the equation, because then I will smoothly move the number from one side to another. So let me remove the square. To remove the square root, I need to apply the squaring for both sides. So squaring here and squaring that, because the squaring will destroy for us the square root. Now, what is the square of 15? It's 2 to 5, 225. Now, the square will be destroyed under the action of, the square root will be destroyed under the action of square. So no square root anymore. And we need to rewrite what is under the square root again. So minus 9 squared plus x plus 8 squared. Now let me square the minus 9 using the calculator, and we will get 81, 2 to 5, plus x plus 8 squared. Now I will move the plus 81 to the other hand side by taking consideration that the sign should be changed from plus to the minus. So 2 to 5 minus 81 is equal x plus 8 squared. Now 2 to 5 minus 81 is just 144. Again, this equation is the equation of one unknown. In order to move or to apply the isolation method, we need to remove the square here. Recall that to destroy the square root, we need to apply the square, and in order to destroy the square, we need to apply the square root. So let me apply the square root for both sides. Remember that we cannot apply something on the right-hand side without applying it on the left-hand side. Now, finally, almost done. The square root of 144 is 12, equal, and the square root will cancel out with the square. And we will end up with this equation. Now we know how to deal with this equation. We just move the 8 to the other hand side by changing the sign. And the answer is 12 equal, or sorry, 12 minus 8 is equal x, then x is equal 3 Newton. So now we know what is the identity of this missing force. F1 is equal 3 Newton. Okay, is the direction of the net force. In the previous section, we determine the direction of the net force graphically, such as if we have two perpendicular forces, then the net force can be drawn using the rectangular shape provided by the F1 and F2. The diagonal of this rectangular shape will represent what? The direction of the Fnet. Now, this representation was a graphical representation or a graphical solution. Now we're going to introduce the analytical solution. From now on, we're going to define the direction to be the angle between the horizontal axis and the Fnet. Now, always we measure the angle from the horizontal to the given vector, such as if the measurement, and always this is going to be the case, if the measurement was from the x-axis to the given vector or desired vector, then this angle should be written as positive angle. So in this direction, we call this direction the clockwise direction. So this is the counterclockwise direction. If we start from here to there to the desired vector, this angle should be written as positive value, for example, plus 30 degrees. Now, what if we have a vector in this direction? Then, when we gonna measure this angle, we should measure it always and forever from the horizontal component to the desired vector. But this way of rotation, it will oppose the positive direction. The positive direction should be counterclockwise. This direction is called the clockwise direction. In the clockwise direction, the measured angle should be written in negative sign, such as, for example, let's say this angle is minus 60 degrees. The good news is we have a formula that will help us to find the sign or to determine and specify the sign as well as the numerical value for the direction or the angle. So let me recall again that the direction from now on is defined by the angle. The angle should be measured from the x-axis to the desired force. The formula that will give us the correct sign as well as the numerical value with respect to the x-axis is given by theta is equal tangent minus 1 Fv over Fh, where Fv is the vertical force and the Fh is the horizontal force. Let me explain how we can do that using a couple of examples. Now here in this question, we need to determine the magnitude and the direction of the net force. So for part A, we have only two forces. This should be represent the horizontal force and this is the vertical force. To find the F net, we need to find or to apply the Pythagorean sum. So F net will give me the magnitude of the resultant force using the Pythagorean sum, and it's written as F1 squared plus F2 squared square root, or you can write instead of F1 Fv and instead of F2 Fh. Now, F1 is 12 squared square root plus 12 squared, and the answer is 12 radical 12. You can express the same value using a decimal number. For now, I will keep this the same. Now, this was the magnitude. So we have found the magnitude. Now we need to find what? The direction. And whenever I ask you to the direction, you should apply this formula. Tangent minus 1 Fv over Fh. Now, in this formula, we should include the signs for Fv and Fh, where the sign of Fv is minus because Fv is the vertical force and the vertical force in this case is F1. Since F1 is downward, then the sign should be expressed as minus. F2 represents the horizontal force and the sign of the horizontal force is plus because it's pointed to the right. So let me complete tangent minus 1. Fv is minus 12 and Fh is 12. Now, let's plug this in the calculator and let me show you how we can do that. In the calculator, first, we should use shift and tan. If we press this together, so shift with tan, we will get what? The tangent inverse. Please double check that you have minus 1 as a power for the tangent. Now let me add the fraction to include the Fv and Fh. So minus 12 over 12, and for sure the answer will be negative 44, 45. So let me write that the direction is negative 45 degree. Now, the same thing can be done here. However, in this case, in question B or part B, the forces, the magnitude of each force is not given. So first we need to determine the magnitude of each force. Let's start with F2. We have 1, 2, 3, 4 boxes times 5 is 20 Newton. And here F5 is 1, 2, 3 times 5. Vertically, it's 15 Newton. Here we have 4 boxes and each box is equal to 5 Newton. So this is 20 Newton. F1 is 1, 2. So we have 2 boxes and horizontally is given by 5. So 2 times 5 is 10 Newton. And finally, for F3, this is 3 boxes, 1, 2, 3. And we should multiply it with the scale. The scale is 5. So it's going to be 15 Newton. Now let's find first the FV and FH. Now FV is the summation of all the forces along the vertical. How many forces that we have? We have the 15 plus, because 15 here is an upward direction, and we have downward minus 15 and minus 20. Therefore, the answer is minus 20 Newton. This represents the FV. Now, what about the FH? Is the summation of all forces along the horizontal axis. So we have 2 forces. The first force is to the right, the second force is to the left. So plus 20 minus 10, and the answer is plus 10 Newton. So this is FV, FH. And FV. Now let me construct a small sketch regarding FV and FH. FV is the vertical summation of the vertical forces, and it has minus sign, so it should be pointed downward. And for FH is pointed to the right because it's a plus. Now, since these 2 forces are perpendicular forces, how did I know? Because we have horizontal with vertical. We know that the angle between horizontal and vertical lines is 90 degrees. The only way to combine vectors at 90 degrees is by applying the Pythagorean sum. And it's given by this formula. Now let's substitute everything that we know about the forces. FV is given by minus 20 with a bracket, and this one is 10. And the F net is equal square root minus 20 square. So again, square root minus 20 square plus 10 squared. كذا دي كالفا. Now we need to determine the direction. The direction can be found using this formula. Theta is equal tangent minus 1 FV FH, which is equal tangent minus 1. The FV is given by the minus 20, the FH plus 10, and the angle is, so let me write here shift tangent. So tangent inverse is minus 20 over 10 and the answer is minus 63.43. What does the minus sign tell us about the direction of the F net? It means that we need to start from the x-axis. This is the x-axis. And we're going to rotate or measure the angle from the x-axis and clockwise, in the clockwise direction. This is the clockwise direction. This is why we have minus. Minus means clockwise direction, and this is the correct direction of the F net with the value minus 63 degree. And this is correct because if we apply the graphical method, we will see that the F net should be below the x-axis, and this is actually what this formula gives us by translating the sign. Now, let's make a recap about the key ideas that we have covered during this lesson. We know that to add two forces together, if the angle between them is 90 degrees, then the net force of these two forces or these two vectors is given by the Pythagorean sum, and the Pythagorean sum is given by F net is equal square root F1 squared plus F2 squared. The same thing can be said for the direction of the net force. This will help us to find a numerical value, more accurate and precise answer to determine and describe the direction, and it's given by theta is equal to tangent minus 1 Fe over Fh. Now, let's solve another question regarding this idea. I will solve B here in this case, and I will solve again question 2. So let's start. Now for B, as usual, if the magnitude of the forces are not given, then we need to find the magnitude. For this case, we should use the scale provided here on the grid. So what about the F4? F4 is 1, 2, 3, 4 times 4 is 16 Newton. This is 12 Newton because it consists of 3 grids, and this one also is 12 Newton. Finally, F1 is given by 1, 2, 3, 4 times 4 is 16 Newton. Now the FV is given by 12 minus 12. This is minus 12 and this is minus 16, and the answer is minus 16. From now on, if you found two equal forces in opposite direction, you can cancel them out. What left is the net along the vertical. Now, along the horizontal, we have only one force, Fh, which is equal to plus 16 Newton. Now, to find the F net, let me draw first Fv and Fh. Fv is to the left with the 16. Sorry, downward because this is vertical, so this is Fv, and Fh is to the right. Now, I made a mistake because I didn't write correctly the direction of Fh, because Fh here in this case is minus 16, it's pointed to the left. So let me write here minus 16. And then I need to correct the direction. So the direction should be to the left. This is Fh. Now let's make complete. Fv squared plus Fh squared. Now for Fv squared, we have the 16 Newton. For minus 16, let me write it as minus 16 plus minus 16 along the horizontal. The calculator would give me 16 radical 2 Newton. Now for the direction, we should apply the formula tangent inverse. So theta is equal tangent inverse. The vertical force is minus 16. The horizontal force is minus 16, and the angle is 45 degrees. Now, why we found that the angle is positive? Why it's not negative? Since it's the direction should be pointed in this way. The thing is, let me draw it correctly first. Now, Remember that this is the horizontal axis. Let's assume this is the horizontal axis. Now, whenever we want to measure the angle using this formula, we measure it with respect to the horizontal axis. So the angle should be from the horizontal axis to the force itself. Now, did we rotate clockwise or counterclockwise? Recall that this way of rotation is counterclockwise and this way of rotation is clockwise. For sure, we have rotate counterclockwise. If the rotation is counterclockwise, then the answer must be positive. And this is exactly what the calculator tell me about the angle. It's positive. Is it important to write down that on the on the answer sheet? No, it's not matter. Doesn't matter. But what matter is you should understand what the number tells you about the situation or the scenario. You should be able to translate and understand what the number tells you about the direction in this particular case. Now, we will solve the last question here in this lesson, or in this video at least. Question number 2. Given the magnitude of the net force is F net is equal to radical 10 Newton, calculate the magnitude of F4 again. What we have here is the magnitude of the F net. They didn't provide me with one of the forces that actually forms this F net. However, in this type of questions, uh, we should start uh, in ordinary way, such as we will assume that the F net is not given, and we're going to treat the rest of the question the same way that we did for finding the F net. So let me first define the FV and FH. So along the vertical, how many forces that we have? We have three forces, 60 up, so plus 60, minus 40, because it's downward, and minus 10. And the answer is plus 10 Newton. So FV here in this case plus 10 Newton. Let me draw FV to be upward. Now what about the FH? For the FH, we have only two forces. One of these forces is missing. We will keep it as an unknown. So let me write here that the FH is F4 minus 80. Why it's minus? Because 80 is pointed to the left, Newton. So we have everything almost to find the F net. So the F net is equal square root FV squared plus FH squared. However, here in this case, we have information about F net. So let me substitute F net here in the correct place. So 10 radical 10 is equal square root the vertical force or summation of all forces along the vertical is plus 10 plus, and along the horizontal is F4 minus 80. Let me recall that we cannot distribute the square over the 80 and the F4. So F4 minus 80 cannot be equal. We cannot replace it by F4 square minus 80 squared. This is wrong. We cannot do that here. Now, the problem in this question or in this line is we cannot move this equation can be defined to be equation with an unknown. The only unknown here in this equation is the F4. We need to find the identity of F4. So you may use the isolation method or any other method that crosses your mind. However, your problem is not by moving things. The problem is uh, you cannot move anything because of the square root. So first you need to remove the square root. The only way to destroy the square root is by applying the square on both hand sides. We cannot apply something on the right without applying it to the left. So to destroy the square root, I need to apply the square for this side and squaring for that side. So square here, square there. Now let me complete. What is the squaring of 10 radical 10? You can use the calculator. The calculator would give you 1,000. So equal. What is the square of the square root? The square and the square root, they destroy themselves. And what left is the terms underneath the square root. I need to write them again. So 10 squared plus f4 minus 80 squared. Now, don't bother yourself with this term. You can square the 10 and move it to the other hand side. Now, if I square the 10, I will get 100. Okay, so now 100, just move it to the other hand side by changing the sign to work on the isolation. Now 1,000 minus the 10 squared, which is 100, equal f4 minus 80 squared. Now 10 minus 100 is just 900, which is equal f4 minus 80 squared. Now what should we do now? This equation is your equation with the unknown. Your target is, or your job is to find f4. In order to find f4, you need to follow the isolation method. However, because of the square here in the bracket, you cannot move the f4 or 80 to the other hand side. You cannot do anything here. So first, you should remove the square. And the only way to remove the square is by applying square root for both sides. So square root here, square root there. So the square root will destroy the square. They canceled out. And what left is the square root of 900 is 30. The square root of this term is f4 minus 80. Now, this is very simple equation. Linear equation can be solved easily by moving the minus 80 to the other hand side. Remember that the 80 must be written as plus 80 after the equal. So 30 plus 80 is equal to 4. At the end, we will get the value of 4 to be equal 1110 or 110, 110 Newton. This is the value of F4 as they asked me to do. I will complete the solution for question 3 and 4, I guess. Now, three forces are exerted on an object as shown in the figure. Which of the following best represent the net force exerted on the object? As we can see here, we have four figures. These figures represent the F net. You can see that only two pictures or two figures have the same magnitude of the net force, 7 and 7. Here we have 11 and 5. So if we determine the net, the magnitude of the net, we may have a chance to determine which one is correct. So let me determine for you the F net. In order to find the F net, we need to find the summation of forces along the vertical and summation of the forces along the horizontal. Let's start with the vertical. We have 5 up and 2 down. The resultant will be plus 3 Newton. Along the vertical, along the horizontal, we have only one force to the left, which is minus 4 Newton. Now, these numbers are special numbers, 3 and 4. Whenever you apply the Pythagorean sum for the 3 and 4, because you're going to add them together, you will end up with this one, this two forces. Then they will give you directly 5 Newton. You can double check using the calculator. So which one of these represent a magnitude with 5? So D is correct. No need to calculate the tangent to find the angle because none of these other choices has magnitude of 5. Now the last question, I guess. Yes, this is the last question. The diagram shows the directions and the magnitude of forces exerted on the path on a horizontal surface. What is the magnitude of the net force? Now, the same thing, we need to follow the same approach. We're going to add all the forces vertically and horizontally. So vertically, we have one force. So plus 2 and minus 5, it's equal minus 3. So we have FV equal minus 3. And here We have 3 and 7, so this is 4 or minus 4. This is FH. And I told you whenever 4 and 3 are appear in the perpendicular forces, the net force will give you FV squared plus FH squared 5. You can double check. So minus 4 squared plus minus 3 squared. So the answer is 5 Newton. So the correct answer is C. I hope you have found this video helpful for you. Thank you for watching and see you in next video soon. Bye bye now.